works, man?
Yeah.
Good.
I watched like 20 minutes ago, and they're doing so much better. It's kind of like or
Right now, we'll text you a call.
okay, yeah, just type it out.
Okay. Hi, everybody.
Good morning.
Welcome to the webinar about international business that it was made up by UNAM Chicago and Facultad de Contaduría y Administración. Today, we're going to have a webinar. The name it is Design Thinking and Product Design by Peter Fanner. So he's talking about his experience about design thinking and product design. So it is my honor to introduce his biographical sketch. Got it? So he's an executive director of UIC Innovation Center, medical device development director in UIC College of Medicine, research professor of industrial design, department affiliate of urology, MDM, Illinois Institute of Technology, BS Applied Science in Environmental Design of University of Canberra, Australia. Peter Fanner is an industrial designer, interaction designer, experience designer, innovator, and educator. Currently, Peter serves as the executive director of the UIC Innovation Center, a collaborative education and development center that operates at the nexus of research, education, and industry. Through targeted programs and initiatives, the Innovation Center brings together students and faculty across a wide spectrum of backgrounds and experience to work on internal and external projects, driving multidisciplinary innovation and inspiring new innovators. Over the past 3 decades, Peter has served as design and creative director of numerous projects around the world. His experience spans mobile communication, consumer electronics, medical office products, furniture, architecture, and material science at consultancies, corporations, and universities. Peter's work has been featured in the Art Institute of Chicago, Mousecat, and Art Institute of Chicago A+D series, Young Chicago, Business Week, Forbes.com, Brand Week, the Cooper Hewitt National Design Museum, Design Culture Now, and ID Magazine, among others. The recipient of ADSA Idea Business Week of Design Hanover, Red Dot Cooper, Hewitt Museum, New York, Good Design, Chicago, ID Magazine, and GP Plastics Designs Award. He has exhibited work at the Art Institute of Chicago, MoMA, New York, Cooper Hewitt Museum, New York, Chicago Atheneum, and ID Magazine Annual Design Reviewer, New York. So Peter holds 70 designs and utility patents, and it is a first dan black belt in Taekwondo. Oh, wow, it is impressive. So, yeah, that is impressive. So to the audience, please keep in mind that after his presentation is concluded, we will open up a space to answer all of your questions. So without further, let me turn it over to Peter.
Thank you, Danae. So first thing I'm going to do is Don Berg, Associate Director of the Innovation Center, will introduce himself and give a quick bio as well. So we work as a team here at the Innovation Center. So Don's going to, the only impressive thing in my bio there is the Taekwondo part. The rest of it's kind of easy. So Don's going to give a quick introduction, then we'll start a quick talk.
Good morning, everybody. Thanks for that. Yeah, so I'm the Associate Director here at the Innovation Center, and a brief history of my experience that makes me a good fit here. I've been an adjunct professor here at the university for almost 25 years. And being an adjunct is actually good because most of my career has been in other kinds of businesses, wide variety of different things, which all, capture experiences for me, which are applied to the things we teach here. But generally, my background is I'm a designer. I've been the design director at the Museum of Contemporary Art here in Chicago. I was a founding member of a company called eLab, which was one of the first ethnographic research companies to apply those principles to design and business problems. So we pioneered a lot of methods and tools that are now very common. I was a vice president of corporate marketing at a company called Sapient Nitro, a big agency for developing websites. I did a startup. I was a partner in a startup called IOTA, which used sensor technologies to capture human behavior. And anyway, and a few more random things. I was a forklift driver once. All of those things, I think, add value to the way we teach students to pay attention to the world around them and understand what it means and how to apply that to innovation. So I've been with Peter for, I don't know, 5 or 6 years. I've been teaching innovation here for many years. So I think we're a good partnership in delivering innovation training to students.
So I think we're going to spin through a document here. And really what we're talking about is design thinking, innovation, something about the Innovation Center where we work, and really the impact we have at the university and what we're really doing here. So really what we do here is we practice and teach innovation. And we do that at the same time because innovation is really about doing stuff. It's not about talking about stuff. And design thinking, that term and that methodology is a big part of innovation. So we're going to wrap that all together in one story, and also talk about the work we do at the Innovation Center a little bit as well. So innovation, what is that? What do we mean by that? So we're asking a question of you guys here. So we'd like some input here from you guys. So this is a somewhat interactive activity here. So what is innovation? Any of the students have some responses?
And rather than using the chat, because of the way we have our desktop things set up here, it'd be great if you could just unmute and shout out answers. And if this is more of a discussion and you can ask questions throughout, that's fine. Or you could save questions at the end. But if you want to participate now, we'd welcome that.
Any responses from the team at UNAM?
Innovation could be make something different.
There you go. Yes. Others? So here are a couple of words that came to us. New or different, yes. Commercially viable, impactful, fills a need. So you need something, so you innovate to fill that need. Innovation is typically applied. So that means it's not an abstract thing we talk about, it's a real thing in the real world. Innovation is also often multifaceted, meaning that it deals with multiple different things at the same time. Innovation is useful, and often innovation is an aggregation of existing things put together in a new and different way. And the last one I think is interesting is that innovation is sometimes really obvious, but it's only obvious once you've done it. It's not obvious before you do it. You know, when someone says, gee, I wish I thought of that idea, it's so simple, that really points to something being innovative. So this is another question for you guys. Why do we do it? Why do we innovate? Any responses? Do we do it for fun?
Because we need to innovate, to create new things.
Yes, there you go. We need to do it. Next. So, and my language on that one is forced to do it. You just need to do it. Otherwise, you won't be competitive. You won't achieve your goals. So, some other ideas here: make money, fix a problem, build brand, engage customers, progress the field, do good, create value, create efficiencies, develop new products, build new businesses, make things better, save time, save effort. And innovation is basically fast and cheap. You can, as opposed to innovation, as opposed to invention, where if you're forced to reinvent something every time you want something new, it's slow and expensive. So innovation is fast and cost effective. So where does it fit? So here we have a spectrum. On the very left, I've called this abstract, academic, and focused. And you see the thing on the most left, we call it research. On the right end of the spectrum, concrete, commercial, and broad, I've called that improvement. So where does innovation fit in this spectrum? And this isn't complete nor correct, so you can challenge me here. But where we think innovation fits is somewhere between invention and improvement. So innovation is really about applying something to the real world. But it's more than just an improvement. And improvement might be incremental in its nature. And if you make enough improvements, maybe you start to innovate. But innovation is also often the application of invention. There's an invention. Someone's come up with something completely new to the world, and we're going to apply it to the world. For example, someone might come up with a new material that's stronger and lighter. It sits there as an abstract piece of material, but if we apply that to something, a car or whatever, we're starting to innovate in that space. So it's between invention and improvement, we think. But often that research and discovery and invention lead to that innovation. So it's hard to remove it from this spectrum. So innovation, how do we do it? How do we teach it? So
yeah, what we'll talk about in the next few slides is the teaching part of it. Innovation is a process. There's a way to teach it. We've done it many, many times. We have a lot of students that participate in classes or corporate sponsored labs here at the Innovation Center. So we've run hundreds of projects through the center, and we've taught methods and process many, many times. So we know it works, and we're very iterative in how we do things here. So we tweak things, make things better, try things. It's like prototyping an experience. We do it over and over again, and we try to make it a little bit better each time. So our standard process, innovation process, looks a little bit like this, which looks like many other innovation models. There's a set of components to them that don't really change much. But the nuance is in how you do each of those things. But the big idea is often you're given a problem, and we often question if that's the right problem. Before we even start, we do a lot of work to understand if what in our case, corporate sponsor, which is how we run most of our programs, they're corporate partnerships. And we can talk more about that later and why that's so unique for us. But we're given a problem, and we spend a lot of time doing some research and understanding the context of the space and making sure that what they think their problem is actually the correct problem. But it starts there, and it does these series of explorations and narrowing down this divergent, convergent idea throughout the whole process. So what those diagonals represent are broadly looking at the problem space, learning as much as you can, talking to as many people and observing how and why and what they're doing, and then taking that research and focusing it, doing some analysis and trying to understand what it all means. So those little decision points, intersections, are areas where we make determinations and decide what the next step should be. And those little round circular things are variations on themes, usually, developing multiple concepts, because there's many different ways to solve problems. So through that center line, we may have 10 or 20 different solution approaches to the same problem. And then again, there we narrow down, test things, take them out into the real world, see if they can be validated. It's really about having hypotheses, building something, testing it, iterating, and doing that again and again. And ultimately, we will have a solution that is often a workable prototype, and we hand those things off to our partners. So, and we'll give you some examples of what that looks like. So design thinking is what this process has been known as. It's not our favorite term necessarily, but it's what everybody refers to and understands. So if you look at these diagrams, and these were just grabbed from a variety of sources, you'll see that they're basically all the same. It's a linear process relatively, although it's always kind of looping back on itself, because every time you make something, you learn something new, and you have to go back and re-examine your starting point. But basically, it's a linear thing. It has some key things like empathy built into it, and we'll talk more about why that's important and where that need comes from. But understanding the user is really what empathy is. The define, ideate, prototype, test. You saw that in the model that we use. Those are all pretty standard components to the design thinking process. So design thinking has a much longer history. After World War II, that's kind of an arbitrary marker, but industrialization, the ability to create mass products for mass markets, and the requirements for supply chain, new kinds of supply chain, understanding bigger groups of users because you're selling to many more people. All of that is quite complex. And Horst Riddle in the 1960s, he was German, from Ulm. He used this term called wicked problem, which you hear occasionally, but design thinking is what that's become. But I highlighted, you can't see it very well, in light blue, some of the terms he was using back in the early 60s. But there are things very relevant and we still talk about often today. Agile thinking, agile approach. He highlights in there complexity, the importance of visualizing work, which is something very embedded in how we do things here. We think we'll take you through a walking tour of the Innovation Center here and show you how the students work, but it's very analog, it's very visual. It's very much about sharing openly whatever's in our head. That helps move the process along. Co-creation, we'll talk a lot about, because that's key also to how we do things. Co-creation is the partnership between the researcher, the designer, and the partner. And when the stakeholder, the partner, is very invested in the creation of a solution, often that makes for a better outcome. The other thing is highlighted in there is values, beliefs, and habits. And those are all user-centered understandings, and there are techniques to figure out what those are, because people's beliefs and values very much determine how they interact with environments and services and objects. And if you don't understand those things deeply, you're apt to get the solution wrong. So design thinking has been, in development for quite a long time, just called many different things. One of the DT there is design thinking. So design thinking solution requirements. What we mean by that is, for a solution to work well after a design thinking approach, it really needs to have these 3 criteria met. It has to be desirable, first of all. People will never tell you this, but it must be something people want and need. And the only way to do that, you can't ask. If you ask somebody something, they'll tell you an answer, but often it's not the correct answer, because it's shaped by a person's experience and background and beliefs and what they've been told in the media and everything else. So understanding desirability is really a science, and we've done that through these ethnographic principles of being in people's spaces, observing how they do things, asking them to self-document in different ways what they're doing and why, and then coming back to them after we've gathered a lot of research and really unpacking it and trying to understand why they do things this way, or why they think about something in a certain way. Viability is a critical business, issue. If it's not financially viable, if it doesn't really fit into the business model, it's probably not the right solution, unless they decide to create a new business around it. But usually we try to fit into their existing business architecture. So it needs to be financially viable. And then technically, it needs to be buildable. So the space that we work in is innovation, not invention. And so we're not, invention is interesting because they will often create ways that you could do something in the future if more components were to come together to make it possible. There's nascent ways to capture energy and things, but it's not scalable. So you can't apply that to broad market conditions. So it needs to be something that kind of exists and is technically not too far off in the future of achieving. That's why Peter mentioned before, innovation is really about bringing existing technologies and things together in new ways. So it's actionable. It's like we could do this tomorrow if we thought about it in a new way. So human-centered, this is, I mentioned I worked at a company called eLab, which was ethnographic laboratory. And this was in the early 90s, a while ago. And we really pioneered new ways to understand human behavior. And we worked for large Fortune 500 companies like Johnson & Johnson and Ford. Polaroid was one of our clients. They were trying to reinvent what Polaroid was back then. But if you look at the top of that image there, it's interviews, shadowing, seek to understand, non-judgmental. Those are different characteristics of building or understanding empathy. And we developed different ways to, when I say deeply understand the user and context, an example of that is Johnson & Johnson. We did a lot of work for them understanding why people cared about cleaning their homes and different tools they used. It's a pretty mundane topic, but it was once you get into people's homes or give them self-documentary tools and let them show you how they clean and why it's important to clean and what their cleaning rituals are and the different kind of tools they use and how they use a vacuum cleaner to vacuum their bedspreads. They would probably never tell you things like that if you ask them. But being able to capture rich detail about people's lives helps you really understand them from their own point of view. And you often get insights. Why would someone use a vacuum cleaner to vacuum their bedspread? It's not something you think about. But if you understand what's driving that, there's probably product opportunities in supporting things, behaviors like that in a better way. So we do a lot of work in really getting into consumers' spaces, their physical contexts, and in their heads to see why they think the way they do about different things. And authentically is important too. We never make assumptions because our assumptions are biased and they're usually incorrect. So we always try to be as neutral and open and honest about these things as we possibly can. I think this is you.
Okay. So another characteristic of design thinking is it's collaborative. And this is actually, Don and I are sitting in the same room in the same spot right now. And this is actually a meeting of the urology department R&D lab. And what you see there is many disciplines, doctors, engineers, designers, business people. But you also see a very different set of hierarchies. So you see undergrad students working with the department chair. You'll see a PhD engineering student working with an undergrad engineering student. And so this interdisciplinarity and lack of hierarchy makes this collaboration happen. And this is super important. UIC is a very diverse university, as you may know, and we really leverage that. You know, even in this picture, you'll see people from all around the world sitting around the table talking about medical devices in this case. So I just kind of mentioned this, but multidisciplinary for us means, yes, you need designers and engineers and business people together, but often you need very different disciplines. Often we have, public health students working on projects. We have computer science students. We use at UIC, there are 16 different colleges, very diverse, like UNAM, and we leverage right across the university to bring students and faculty together from different disciplines to work on a single project.
And I'll add to this image here. Who you see in this picture are, there's a management informations person, there's a industrial designer, and a couple of computer science students all working together in one of our corporate partner labs, which is Caterpillar. So Caterpillar has been funding a lab with us for 10 years almost, and we've taught classes around topics for them. But we tackle a wide range of problems for CAT, some technical things, but mostly human-centered things, why people are doing what they're doing, and blending human-centered problems with technology problems. So these students who work in these labs, they know nothing about Caterpillar or heavy equipment, but they have learned this design thinking process, and they're able to apply the steps in the process to these wicked business problems and give Caterpillar new insights on how to think about them, because these are people who aren't embedded in their system, don't have a long history of working in, mechanical environments. So they question everything. Why is this way? Why do you behave this way? How come the thinking process is this way? So they really bring a refreshing but well-informed set of questions to Caterpillar.
So design thinking at its kind of core is a problem-solving process. And to do that well, you need to integrate multiple perspectives. So we do a lot of medical work here, and if we're working on something, medical, you need to understand the patient. You need to understand the business. You need to understand the technology around it. The competition, what are they doing? You need to understand how a hospital works. You need to understand the insurance company and how that can inform the business side of things. You need to understand what the surgeon thinks of the issue or the nurse. So this multi-perspective viewpoint is absolutely critical for success. And what we find is the design thinking process helps one integrate these often difficult and seemingly contradictory perspectives. And I think that's the role of the innovator or the design thinking person, is to integrate these different perspectives. And that way you will come up with a solution that is, successful. Because if you leave out any perspective, it's not going to be successful. It just won't work in that situation.
We talk about these people as stakeholders too, because each of those play a significant role, and they all have different relationships to each other. And some people are unaware of different actors in the system, and some make their decisions based on what another stakeholder needs.
So we often use a term called lateral thinking, and that's the kind of opposite to linear thinking, right? Linear thinking, you do A first, then B, then C, then D. And what design thinking does, it embraces lateral thinking, which means there's not a specific order in the way you do things. You need to integrate and join the dots between these different perspectives. And, that might be, looking at a new invention, but also looking at existing technologies as well, and emerging technologies, and start to understand the relationships between these different viewpoints and perspectives. And really, innovation comes from, you may not be inventing anything, but you assemble these different things in a new and different way, and you've come up with a solution that is innovative. So here's an example here. On the left is a urinary catheter, and we were looking at a way where we were working on a project where one had to measure urine output. And we looked at all sorts of technologies, and there was a product on the market which is called a Camelback. And if anyone is a runner or a cyclist, you'll know what that is. It's a way of carrying your water in a little bag on your back. And they have a device which measures how much water you're drinking, a simple thing that measures the flow of water through that blue tube. And why would we not use a technology that already exists, but in a different way? So we leveraged that technology to measure urine output, which was very effective without having to invent anything. So looking at other places, industries, and contexts helps that design thinking come up with this innovative process, this innovative solution here. So design thinking is also iterative. These drawings may be hard to see, but basically what you do is you come up with a solution. Is it right? Is it not right? And if it's not right, you progress it a bit more. So you iterate, iterate, and iterate until you get to the point where you have a solution that meets all the criteria that's needed. And often that, in some cases for us, that's many different iterations. And you might iterate to a point where you realize it doesn't work, then you start again. So the iterative piece is important, either to get to the right solution or get to a solution that is not right, and you go back and start again. So it's iteration is certainly part of the process.
So what was this particular project?
This was a project to do with rehabilitating people who have suffered a stroke, and they had some paralysis in one of their legs. And this was a way to make really uncomfortable socks, which you would put on the side of the body which wasn't affected, which forced you to walk in a normal manner by putting weight on the leg that had been affected by paralysis, therefore increasing or speeding up the recovery by about 50%, which is pretty impressive. It was it just forced you to, rely on your leg that had been affected.
So prototyping and testing is something we're very good at and something we deeply believe in. And we push that quite a bit. I'll talk about the ones on the right, the glasses. This was another Caterpillar project, which was really interesting. They asked us to look at site safety, which is a big issue in construction, how to keep people safe on busy construction sites. Caterpillar does all kinds of large-scale construction site projects, highways, whatnot. There's sometimes 500, 600 pieces of equipment. There's also lots of pedestrians on the ground doing measurements and all kinds of things, walking around the site. So, and there's injuries. People get struck by heavy equipment or crushed or caught between things. And everybody, the construction site owners, everybody wants to figure out a way to reduce these by 100%. And right now, there is no real solution. If you're all aware of trucks backing up and they make beeping noises, that's kind of the go-to solution at the moment. And nobody pays attention to that anymore. It's more of an annoyance than, a help oftentimes. So what we did was start to look at how to shift the weight of, responsibility, I guess, onto those pedestrians rather than having all of the burden on the heavy equipment operator. They're already thinking about, 20 different things, and to also be paying attention to small people down on the ground is just one more cognitive piece that they have to build in. So it's not ideal. So what we did is, there's two parts to this, which are interesting. One is understand where on the human body you could send a signal to get them to turn in a direction where the danger is coming from. So again, through rapid prototyping, we used haptic alert sensors to, on different parts of the body to see if we could get them to rotate in the direction where something is coming. And we would test it by putting little haptic things, taping them to the body and throwing tennis balls at them and give them a haptic alert and see if they could turn their head before they got hit by a tennis ball. And so it was kind of fun, but it worked really well. And we tried enough body areas where we finally got to this small bone that is behind your ear. And we found a very slight haptic alert to either the left or the right would make your head turn in the correct direction. So once we figured that out, another team was simultaneously working on an algorithm using machine data, because all these Caterpillar machines have tons of sensors, and they're always reporting different kinds of data to the cloud to be analyzed later for different maintenance reasons. But there's data that we can configure to tell how fast a machine is moving, what direction it's moving, and alert only the people that are in the path of danger. So no one, if a machine is here and there are people all around it, there's no sense in alerting 75% of the people who aren't affected to that danger. So we aimed it to only the pedestrians who were in the path of danger. So those two things, that algorithm and the technology to get them to pay attention to the right direction, made for a very effective new safety device embedded in these safety glasses, which most, if not all, construction workers are already wearing. But that was a series of, we maybe did this over the summer, and we prototyped and tested, 10 different opportunities for doing this until we narrowed it down to this one. On the left, you want to talk about that?
So this is just one simple picture of, we were working on a device for eye doctors called a scleral depressor, which is a device you push on the eye and you look in the eye at the same time to see how that change in pressure in the eye affects the internal structures of the eye. And the way this is done, typically there's a little tool called a depressor and someone with a light. And we decided that wouldn't it be useful if that light was embedded in that actual depressor? So the surgeon freed up one hand. To make that, it seems like a very simple idea, but to make that happen took hundreds of very simple prototypes to try and get the right amount of light, the right pressure, and get that light flowing into the eye. So just prototype after prototype after prototype, test, and you ultimately get there. So prototyping is just a super tool for understanding what's happening. And prototypes can be also very simple, like the Caterpillar one Don described is actually quite complex. The scleral depressor, really simple, 3D printed parts with a little light emitting diode in the end of it as the basic prototype.
I think another thing to mention here is at the beginning, the slide deck was titled Process, Methods, Mindset. And mindset isn't something we actively teach, but it's kind of embedded in everything we do. The act of making something and seeing if it works, that's, for a lot of people, that's a big risk. Failure is not something people look forward to. And doing these tests, they're more often than not failures. And helping students learn that prototyping, testing, trying things is really, that's an active, positive part of the process. That's a mindset shift. Because more often than not, as I said, things don't work the first time, and you have to radically rethink why you thought it would and try a different approach.
Yes, just to build on that, it's highly unlikely that your first prototype will be the solution, and it may not even work at all. It might be a complete failure. You might learn something from it in that process, but generally you need to keep that expectation appropriate for where you are in the project. So these are some references that you should read and look at. And there's many things out there. These are just a few that we look at from time to time. So we can send this list down to you, and I'm sure if you haven't got these in the library, we could kind of point you to them as well. But they're a mix of process books, business books, and it's kind of the intersection of all those things coming together. So that's So we're going to quickly spin through the Innovation Center and what we do now, because that's some sort of theory behind things, but now we'll get a little bit more practical. So this is a photograph. You can see Don there working in Cat Lab. And in that picture, there's students from multiple disciplines. There's a computer science faculty. And you can see the kind of space that we work in is very kind of open, with the work very visible. And this is important because someone walks by and sees something and says, oh, I got an idea about this. And people start to collaborate without having to like have a formal meeting. It just happens by default. People see something, write a note, stick it on there. So the way we work at the Innovation Center, we teach and deliver innovation through, primarily corporate sponsored classes, labs, and projects. So there are classes where there's students getting credit and they're working with a corporate partner. And, a lab is something that's, more permanent. And often we work on individual projects with corporations or internally with the university. So we believe diversity improves innovation. It's more than a belief, we know that to be true. Having a diverse set of disciplines is obviously very important, but having a diverse set of perspectives is just as important. Students from all over the world, and they say, well, at home we did it like this, or at home, oh, this is how I saw it when I went to so-and-so. So that diversity is just super important to us. So another thing we do at UIC is this is kind of an odd term, the front door to UIC for our corporate partners. So we work with Caterpillar, and we'll see a list of some of the other companies we work with, but some quite big companies, and we help them with R&D projects, but we also help them find students to hire. We also help them connect to research that's going on in the College of Engineering, let's say. So we work to get our partners embedded more broadly at the university, which is valued to them because they find new students and faculty and so on. So some of the partners that we have worked with, and you'll see some fairly well-known names here. Currently, we're working with Baxter, Granger, Hillrom, Caterpillar, Bosch, Cardinal Health, Hollister, and you'll see quite a mix of different kind of corporations there too. So, if we have a medical corporation, we might have bioengineering students and med students working on the project. If it's Caterpillar, there might be mechanical engineers and computer science students there. So all of these partners have different needs and desires. So we try and build teams that support the needs of the project, but also the future needs of those partners. We also work with many different colleges and departments across campus. I think we had like 16 different disciplines working here, something like this. So business, public health, design, liberal arts, medicine, engineering, obviously a lot of engineers. And this is a really enriching experience. And it helps the students understand how to work with different disciplines. Because a lot of engineering students, they're in their 4th year and they've never really interacted with anyone else but engineering students. So it's very important they learn to work with designers or business people, because that's the real world. So one of the things we do here is really prepare students for a real job. How is it that yes, they have their technical learning from engineering, but you need to be able to work with other people to amplify that knowledge and skill. So we do a lot of getting students working with other students, but also we get students to talk about what they're working on in front of different people. Often it's university people or a visitor comes in and we walk them around and we show, the students show their work to these people. And that's very, very important to be able to explain what you're doing in 30 seconds or a minute to someone who has no understanding of that topic. And this is a picture of our future building. So we're sitting, if you see on the right-hand side, there's a red brick building, which is actually an old supermarket, which the university gave to us, which is very kind of them. But the piece on the left is a new building, new extension to the building we're working on. So we're about to double our physical space, and that will help us do more corporate work. We'll be able to start a student incubator, and we'll just have more space to do what we need. So thank you, and questions for Don and myself. Then we're going to spend a little bit of time walking around the center with a camera, so you'll see kind of physically what we have here. So questions, please.
Okay, thank you. I'm going to start with the first question. The first question was, what kind of leadership profile should the decision maker have?
Well, decision making in a project or in...
Yeah, from whose side are you talking about? From the client side or from the team doing the work side?
I think that they're talking about the team side.
So I'll give my perspective first. I think that there is no one decision maker. I think decisions are made, at least from our perspective, in a very collaborative way. And, this is my personal opinion. There's one way of thinking that says the decision maker is the boss who makes a decision. I'm making that decision. And I'll give you a couple of examples of why I think that's not the way forward. Because often the person that is the boss is not the expert on the topic. And this happens all the time. I'm in a position where I have to make decisions, but I will speak with Don or Tomoko or any of my staff, or often the students working on the project, to make a decision about this. And even the other day, we were in a meeting with Chancellor Reyes, and there was a decision about our new extension. And he's the boss of the university, right? And we had a discussion about one part of the design of the new building, and he said, well, I don't think this is the way we should go, but you guys are the experts. You make the call. You make the decision. And to me, that's the right kind of leadership. Is yes, you need to understand about the decision, but often you defer to the people who are best suited to make that decision and let them do it. And that's not a sign of, to me, that's not a sign of weakness. That's a sign of really strong leadership. And you need to be confident in that decision too, and in your people. But yes, that's the way I go about it. And now, Don, you can give your answer on the same question.
On the same question, we were talking about leadership.
And decision making, yes.
Well, I had to go find somebody, so I didn't hear anything Peter said. So forgive
Don's
me.
going to start. I'm getting a glass of water, by the way, so I'm not walking away.
I'm going to talk about it unless he already did, but from the student perspective, we teams, as we said, they're very multidisciplinary. They're also very, in terms of hierarchy, we could have PhD students in a project team with, second year or third year students. And you would think, older, more experienced students should be in a leadership role because they've been here longer. But that's never the case. It's only lately that we've been testing a model where a student will take the lead on a project because they've been here for a number of years. We often will get a third year student who had a class with us and learned and was interested in some of the things we're doing here. And then they'll participate in a lab and they'll stay in the lab for 1 or 2 years, and then they'll graduate and be an alumni, and we'll hire them. And they'll stay on here at the Innovation Center for a couple of years. So those people get a lot of experience and a lot of, they learn a lot of skills, and they also get a lot of confidence. So those people tend to lead projects, but they're also very recently students. So they have a lot of empathy for others on the team. And maybe they learn it here, or maybe those people are attracted to us. I'm not sure how it works, but they tend to be good collaborators. And they know that collaboration really is about deferring to other people on the team and being open to different points of view. I think leadership fails when you have a very strong point of view that you enforce and don't listen to other points. So I don't know if that's exactly what Peter said.
Almost word for word.
So I guess that's why we are partners in running the Innovation Center.
Yeah. Often a couple of things can happen. Often the person that's, let's say, financially responsible for the project likes to make the decisions. And that's also not the right approach either. To me, it's a totally collaborative, you arrive at the right decision through collaboration. Does that make sense to everyone?
Yeah, totally. And also this methodology that you are using, it's very interesting because the implementation that you are taking up, it is also trending because the results were obtained. Now I'm gonna make the second question. We have a few more. The next question is, can design thinking be applied to any type of organization or project?
I would say yes. And maybe there's some things that it's marginal, but I'd say generally yes, because it's really about understanding the need when it comes down to it, and understanding people, because at the core of most problems there are people and needs. And I think that's, so I think that yes, there may be some super abstract technical problems that may not be as beneficial, but generally the things that certainly we work on, you need to understand, the needs, you need to understand whether it can be achieved and that it can be a viable business. Otherwise it will fail. So I'd say yes, as a general answer. Donnie?
I would say even more strongly, absolutely yes. I think, and we've demonstrated that here in the wide variety of projects we've done. A lot of things are product focused, like we want to create a new product or service within a market space. So it, obviously fits there. But we've also been asked to look at processes and organizational models and systems, within those organizations and how things work, and rethink how something should work. An example of that would be the university has asked us to be on a committee to look at medical curriculum. How is teaching medical students, how could we evolve that to be more effective? And it's absolutely a design thinking process, understanding what students want to learn, understanding how it's being taught, understanding the sort of, the dogma that's embedded in the system, and how to get people to challenge what is in order to make something better. So that is all about, running through what if scenarios. Well, understanding how it's being done, understanding where you want to get to, and then creating new scenarios to run and test through that. And also creating a spirit of open-mindedness to wanting to try something new. So all of those things I think are embedded in design thinking methods and approach.
Yeah, I'm going to add something to what Don said too, which he touched on, is that so the design thinking process, and we use other terms for it too, but that process of bringing people together of different disciplines, looking at the bigger picture of things, it's good for delivering results, but it's also very, very good at building culture. And that culture of openness and sharing and collaboration, that helps for the next project and the next project. And at the university here, we think that we're slowly having impact on the culture of the university, because we work on some university projects. When the COVID pandemic hit us, we were asked to help set up the COVID testing protocols and physicality on campus. So Don and I, a couple of summers ago, were working on COVID testing, and we knew nothing about actual COVID testing, but we knew what we could do to help people or encourage people to go get tested. So we worked on that project and set up the testing methods. So yes, it's generally applicable. Sure.
And we did that through prototyping. We had a big arena, right? A big, I don't know how 20,000 square foot facility. And we all sat in a room talking about what we could do and what we should do and how people would move and where the stations were. And we said, why we shouldn't be talking about this out of the context of the space. We need to go over there with a bunch of tape and barriers and chairs and desks and set up something and just run people through it to see what they do and then adjust things appropriately.
Yeah, it was really interesting, building a prototype inside an auditorium with some rolls of tape, some furniture that was there, and just, mocking up what the test would look like and how long it would take. And, say we need this many and we did this and this. It was, without that, it would have failed. So yes, is the answer.
Thank you. Okay, the next question is, in your experience, what differentiates design thinking from other methodologies such as Scrum or Lean Startup, and which one is better?
Oh, I guess from our perspective is that we don't make those distinctions. Often what we do is mix these different ways of working together, because sometimes we want to add, everything we do is pretty lean startup methodology too, about understanding the needs and the viability before you commit to too many resources. This is also, Caterpillar uses the lean innovation method, which is basically that. So I guess we don't make those distinctions. Maybe there are some tools and methods that are more appropriate for certain types of projects. But yeah, and I guess that comes from experience too, of what approach you take to a specific problem. Don?
Yeah, I think the other thing we try to do is we have so many different types of corporate partners, and they all have their preferred method and vocabulary and approach. So we do our best to adopt their language and their tools. And I think what we find is that, lean innovation is the same thing as what we call X, right? So we're not relearning how to do things. We're maybe tweaking things a little bit, using sharing technologies. I'd never really heard what a Scrum Master was until I started working for Caterpillar, and they had whole workshops on Scrum and Scrum methods, and it's like, oh well, this is really just
when you give it this name.
Yeah,
right?
And so yeah, they're very similar, and I don't think any one is better than any other. Maybe some are more suited towards engineering development things and others for something else, but they're all very similar and can work together, I think, and support each other.
And no one's really done this, but I think the opportunity to kind of codify all these processes and say, well, this is best for this kind of project, or when you combine A with B, this is a really good result. And we're starting to actually do that here ourselves, is, to say, well, for this kind of project, these three things together work really well. And the team look like this. So start to kind of describe the ways we're working, and not kind of stick with one process dogmatically. So if you wait a couple of years, we'll probably, Don and I'll probably have a book on that topic of which process to use for which kind of problem, or more importantly, which things in combination work well together.
We do something here which is like super duper lean innovation. We call it a phase zero approach. And it really centers around that. If you remember that diagram that we use, the process diagram, that starting point of what the problem is, because often a sponsor will come to us with a problem, but they're not really sure how to frame the problem exactly. They know the problem space and they kind of know elements to the problem, but they're not quite sure exactly what it is. So, we'll do a super quick 4 to 6 week SWOT kind of approach on that problem space and really help shape where we start. Because if you start going down the wrong path, you can go a long way before you're not
Right
in the direction you want to go.
So this is very, very clear that you're not working on a solution. This phase zero thing, it's, no solutions. Just like, what's the need, what's the problem? And that definitional piece early on sets you in a good position to come up with an appropriate solution, or a good solution, or an innovative solution.
Okay, thank you. With this last question, we ended up. The last question, it is from Jacqueline Nieto, that she is watching us through YouTube. So hi, Jacqueline. Okay, the question is, your partners are very diverse, like Wilson here in Mexico, we know for the clothing and sports products, even Dunkin' Donuts. How are your projects with them, and in what areas?
So the way we work is interesting in as much as it can be applied to pretty much any problem. This goes back to the previous question, really, that if there's a problem or a need, we can pretty much figure out an approach and a solution. So without too much detail, the projects that we work on, we're working with Dunkin' Donuts, who, everyone knows Dunkin' Donuts, right? Was really around a couple of things, around efficiency in their, kitchens, and also some really interesting things around training of their workers, and basically efficiency in their kitchens. And the way we approached that was really interesting. We actually built a Dunkin' Donuts kitchen here in the Innovation Center. And we actually have a couple of Dunkin' Donuts franchises here on campus, and all the students working on the project went and worked in Dunkin' Donuts. So they were fully immersed in what it's like to work there, and the situations and the complexities. So while the projects are kind of different, the processes were the same. So with Wilson, obviously you know them, we worked on how to make tennis actually more accessible to people. So in the States, tennis is, it's not so accessible. You need to belong to a club and so forth. And that's a limiting factor for Wilson. They like it. I grew up in Australia. In Australia, we play tennis on the street, right? Like you hit a ball back and forth all day, just on the road. No tennis court. And that was a very normal thing for us to do. So Wilson was looking at how can you make tennis more accessible, not just in the States, but in other countries as well. And again, it was around understanding the needs and the potential needs of potential, Wilson, customers and what they wanted to do. So there was a number of solutions around that. Simple things from making it easier to schedule courts if you had access to courts, but also making tennis, so you could play it in a much smaller space. And having one of the solutions was actually a net that wasn't a physical net, it was digital. So you didn't have to string up a net. You could just like hit the ball across, and if it went through an array of LEDs, it was like hitting the net. So a bunch of solutions. Fun.
Yeah, no, it's both of those projects were in class situations as opposed to labs. So 2 semester classes, usually business students, engineering, and some form of design, industrial or graphic. So it's probably a good example of how any group of students can work with any kind of corporate partner on any kind of problem and deliver some interesting results. The Dunkin' Donuts one was really a really good class. It was fairly product focused, like designing artifacts. Dunkin' Donuts are unusual because they have really small kitchens. They have really wide variety of offerings. It's not donuts, it's donuts and lots of different kinds of sandwiches and other things. And they end up they're not like McDonald's, where a McDonald's will have a whole building and it's designed, for production efficiency. Dunkin' Donuts, at least here, are often, in a corner of the gas station or, in odd areas. So they have many different kinds of kitchen configurations. And what that does is lead to poor standardization of food products, right? And Dunkin' Donuts in Prince Castle, who is the manufacturer of the kitchen equipment, partnered on this to try to find, create new tools for better standardization and more efficiency in producing the things they were producing. And the students, they produce things. One was, and they listened to customers, like, well, what's not working well for you? And a lot of customers complained about the variety of cream cheese on their bagels, right? Like, why so much frickin' cream cheese on my bagel? And so they produced a tool where one turn, gave you the exact amount of cream cheese for the bagel each time. So you got a very standard product. Or another problem was, putting out a tray of hash browns in the oven very quickly. The way they do it now is they put down all these hash browns one by one, and it takes, almost a minute to do a tray of hash browns, which doesn't seem like a big deal. But if you're, a big franchise like that, it creates long wait lines, and they don't want that. So a team generated this, this dimpled tray where you throw a bunch of hash browns on it and shake it a few times, and they self-distribute, right? And that took less than 5 seconds. So, little things, that seems like, well, whatever, but those little things add up to, across massive scale, they really make a big difference.
Yeah.
Okay. Yeah,
So,
I agree with you. Tell me.
what we're going to do now is we're going to walk around.
No, I'm gonna say thank you. First of all, Peter and Don, thank you for being here. On behalf of Facultad de Contaduría y Administración, thank you for giving us such a valuable presentation. It was a pleasure for me to be here as well. And well, you are invited to the rest of the days to watch us through YouTube. Okay, because we're going to have more webinars.
Okay, good. But now we're going to spend a few minutes walking around the center.
Okay.
We've got Spencer. Come here, Spence. So this is Spencer Melgren. Spencer was, he now works here. He was an industrial design student here at UIC. And we've got a camera on a tripod on wheels. So Don and I are going to walk around, and Spencer's going to turn that camera on.
It needs to be led to the meeting.
Oh, how do we do that? Can you see if there's, what's the name of that computer?
Test.
Can you see if there's a
Oh, got it.
Oh, you got it?
There you are.
Where are you? Okay, test, that's good. And turn that camera on.
And mute.
Oh, no. We'll have to, you have to use a video from this camera from this laptop and walk you around, right? Okay, so we're going to walk around now and we'll show you where we work. And there's a little bit of echo now, but we're going to walk backwards, right? Don? So as I mentioned before, this is an old supermarket. So you'll see kind of hints of
No.
Okay. Are we good? Yeah. So you can see some prototypes here that we kind of keep this display. So this is our main classroom space. There's finals week this week, so we'll see students presenting here tomorrow and Thursday, I think. Open workspace. It's pretty early here, so there's no students. Workshop, prototype shop, where we make stuff. We can pretty much make anything here. We're pretty well equipped. He's out here. And here we have some lab spaces. We work with our urology department, designing the medical devices. Ophthalmology here. This is a project we're working on, which is a robotic operating room, and you can see a low fidelity prototype of operating room here, where we're testing some ideas and configurations. So again, building, prototype. And this is a fairly heavy, a lot of prototyping work here.
You notice everything is made out of foam core, so we don't spend an enormous amount of time on some of the small incidental things, but a lot of energy goes into the robotic arm and how it's moved within the space.
Yeah, which is the core of the project. And we have Grace and Andy in there. They're going to come and wave to us. We've got UNAM on the video here. Yeah.
Now we're walking into a corporate lab space. Thank you, Charles. Sorry about all the bumpiness. We're doing a tour.
I got it.
So we are, we have a team here working for a healthcare system, and a typical meeting space. You can see, we talked earlier about the value of putting lots of things up on the walls, so we all know where we are. It's good for telling stories. We have lots of people who do tour through here physically, and putting evidence of the work up and being able to talk where we are in the process is really valuable. But we have, this is a typical team with many different disciplines represented, alumni, master's students, and recent students. So it's a good example of a thing. Maybe we can walk around, see what's going on with Caterpillar. we're near the end of the semester here, so most of our students are in classes in the finals, so usually more people here. This is probably a good wall to stand in front of. One of the projects the team is working on is understanding data for Caterpillar. This is a Caterpillar space we're in. And understanding users of the particular data they're interested in. And the team did a lot of interviews with different people at CAT, different customers, different business unit owners. And some of them have never met each other, right? Most people, it's a huge place. They're doing very distinct things. So there's a lot of siloing in the organization. So they kind of worked across all of those silos, across many different business units and user types. So what they were trying to do and what all the string represents and little arrows and triangles and stuff are connections between people and themes and problems, and starting to build, understandings across the full system, not just a particular individual. And that's a big problem all large organizations have is, narrow focus on one domain and not looking at the broad system. And that's one benefit that we bring to the party, I think, is we don't understand those domains deeply, and we're not embedded in them. So we can question why things are segmented up the way they are, or why there's lack of communication between different groups, or why one group uses a technology to one thing when a different group doing a similar thing uses something completely different. So this kind of visualization, capturing of what's going on is super useful in understanding the big scope of something.
Okay, thank you, Peter and Donald. I think that for a matter of time, we need to cut the transmission now, but we thank you so much for all you have done for us, and what you show us to us today was great.
Thank you for the opportunity, and we'll see you soon.
Yeah, thank you. Have a nice day.
Bye-bye.
Nice
If
to meet
you see
you.
Javier, our chancellor, say hi.
Thank you.
Okay, bye.
Ciao.
Ciao.
Bye.